Okay, so now in section 7.3, we're going to be doing about the same thing we did in chapter 6. If we have small samples, we need to be using the t-distribution. So let's see how we use the t-distribution. Now this test is easier using the critical value approach with the t-distribution because the t-distribution table that we have is set up perfectly for that. So the first thing you need to do is identify the level of significance. From that, then you identify the degrees of freedom. Then you use table 5, which is your t-distribution table, and find the row with n-1 degrees of freedom. If the test is a left-tailed test, then we use the column, but we change the number and put a negative sign with it. If it's a right-tailed test, we use the number in the column with a positive sign, and if it's a two-tailed test, we use both the negative and positive sign. For example, suppose we're trying to find the critical value for a left-tailed test given significance level of 0.05 and n equal to 21. Well, if n is 21, then the degrees of freedom is 20. So we look across the table to find the row that says one tail alpha and the column that says 0.05. And then, because the test is a left-tailed test, we look for the row that's degrees of freedom of 20, and we see that value is -1. We see the value in the table actually says 1.725, not positive or negative. But since it's a left-tailed test, the critical value is -1.725. Let's do the same thing now for a two-tailed test. There is a row at the top that says two-tailed test. We look for a significance level of 0.10. If n is 26, we go to the row where degrees of freedom is 25, and we see then that the critical value is 1.708, and because it's a two-tailed test, those critical values are plus or minus -1.708. To do a t-test for the mean, when n is less than 30 and the population standard deviation is unknown, we will be doing what's known as the t-test. And we find the standardized test statistic exactly the same way we found the standardized test statistic for z. It's the sample mean minus the claimed value divided by the standard deviation, and that's divided by the square root of the sample size. The degrees of freedom then is n-1. The steps are, first you state the hypotheses, you specify the level of significance, you identify the degrees of freedom, you determine the critical values from the table 5, which is your t-distribution table, determine the rejection regions, find the standardized test statistic. If the test statistic is in the rejection region, you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis, and then interpret the decision in context of the original claim. So let's look at an example. Suppose a car dealer claims that the mean price is at least $20,500. At least is greater than or equal to, so our claim is the null hypothesis. And so we go out and take a sample of 14 vehicles and find the sample mean is 19,850 with a standard deviation of 1,084. We're going to use the significance level of 0.05 to test the dealer's claim. So remember, the claim was at least, which means greater than or equal to. Its complement is less than 20,500. We have a significance level of 0.05, and since our sample size was 14, degrees of freedom is 13. We use the t-distribution table for this is a one-tailed test, and we look along the top column to find alpha being 0.05. We see that value is 1.771, but because it's a left-tailed test, it's -1.771. We calculate the test statistic, sample mean minus claimed value divided by standard deviation, and that's divided by the square root of the sample size, and get -2.244, which is inside the rejection region. Thus, we reject the null hypothesis, and at the 5% significance level, we say there is enough evidence to reject the claim that the mean price is at least $20,500. Let's look at another example. Suppose an industrial company claims that the average is 6.8. The average pH level is 6.8. Is, it stands for equals. So the claim is the null hypothesis. We randomly select 19 water samples, and we find this, the mean of these 19 samples is 6.7 with a standard deviation of 0.24. Is there enough evidence to reject the company's claim at the 5% significance level? Well, the null hypothesis is 6.8. Its complement is not equal to that. Makes this a two-tailed test. Significance level of 0.05. Degrees of freedom is 18. We go to our t distribution table. We are doing a two-tailed test, so we go to the row at the top that says two tails. We find a significance level of 0.05. Go down to the row that has degrees of freedom being 18, and we find that that value says 2.101. Because it's a two-tailed test, negative 2.101 is the bottom, that is the cutoff for the bottom rejection region, and positive 2.101 is the cutoff for the top rejection region. We then find our test statistic doing sample mean minus claimed value divided by standard deviation, and that's divided by the square root of the sample size. We get negative 1.816, which is over here someplace, not in either of the rejection regions. So our decision is to fail to reject the null hypothesis. So our conclusion is at the 5% significance level, there is not enough evidence to reject the claim that the mean is 6.8. That is the end of hypothesis testing. Now you need to go practice some problems using the t-distribution test. And some of the homework problems will ask you to use technology to find p-values. Just skip those sections. Make up a number. You're going to miss it. That's okay, because there's so many parts that that piece that you're missing is still going to round up so that you got that problem correct. And so ignore the problems where you have to find a p-value. Just enter any p-value you want in there and just move on. And you'll get the rest of the problem correct. And you'll get credit for doing the problem. So go to homework 7.3 on the My Math Lab Course Compass website. And that's the end of hypothesis testing. We will not be doing hypothesis testing for proportions or hypothesis testing for standard deviation in this class. But if you wanted to, you have the PowerPoints for section 7.4 and 7.5 if you wanted to review that on your own.